In this video, we're looking at parallel and perpendicular lines. So the gradients of parallel lines occur when there's two lines that are exactly parallel. They have the exact same gradient. So remember, parallel is if I have two lines going like this, and they go on forever and never touch. So if I had the top one, that would be my M1, and that would be M2 there, right? So M1 equals M2. Now, if it's perpendicular, they cross. So here, if I have two lines, they cross at a right angle there, okay? So you'll see sometimes the symbol like that. That means the perpendicular. Now, that equation is M2 equals negative M1, 1 over M1, okay? So if we had to do an example here, we need to find the gradient of a line that is parallel to y equals 2x plus 1. First thing to find is our gradient of the original. And remember, this is nice and neat. We're using y equals mx plus c. So we know for this one that m1 is going to equal 2. And we know for parallel lines that m1 is going to equal m2. So we know that m2 also has to equal 2. So that was easy. Parallel lines, they're the same. m1 equals m2. Perpendicular lines. So here we need to find the gradient of a line that is perpendicular to y equals 2x plus 1. Now we've already found what m1 is, so I'm going to write that down. m1 equals 2. And we know the formula for this is m2 equals negative 1 over m1. So if I can substitute these in, we know that m2 is going to be negative 1 over 2. Alright, so the gradient of a line that's perpendicular to y equals 2x plus 1, its gradient is negative 1 over 2, or negative a half. So here's our next problem. Find the gradient of the straight line perpendicular to the line with x-intercept 3 and y-intercept 2. So the first thing we need to do is find our gradient. Now, I'm going to just write these out a little bit more in a better way. So the x-intercept is essentially 3, 0. The y-intercept over here is going to be 0, 2. So 3, 0, 0, 2. x1, y1, x2, y2. Now you may know where I'm going from here. I'm going to find my gradient. So we know that the gradient of this line, so m1, is y2 minus y1 over x2 minus x1. So substitute in our values. So 2 take away 0 over 0 take away 3. So we have negative 2 over 3. Now, remember, if we're trying to find the line that is perpendicular, right? So we're really trying to find m2 equals negative 1 over m1. We know what m1 is now, so we end up with m2 equals negative 1 over negative 2 over 3. So you can put this into the calculator and our answer comes out as 3 over 2. Now if you didn't want to use a calculator, just so I can show you, this is going to be negative 1 divided by negative 2 over 3. We don't like dividing by fractions, so we find the reciprocal by flipping this, and we add negative 1 times 3 over negative 2, and that ends up being negative 3 over negative 2, and the negatives cancel out, so we're left with 3 over 2. Alright, so that's all we had to do for this, was find the gradient of the straight line perpendicular, which is what we did there. And we'll go on to another example now. So go down, find the equation of the straight line passing through 7, negative 2, that's perpendicular to this. So the first thing I'm going to look at is this here, okay? That's the important part to start with, because we can use that to find our gradient. So if I rewrite that, 3x minus y minus 5 equals 0, and let's rearrange it by plussing the y, I end up with 3x minus 5 equals y, or y equals 3x minus 5. So I know that my m1 here is going to be 3, and we can find our line, it's perpendicular, so I know that if I'm trying to find m2, it's going to be negative 1 over m1. So the gradient of the line we're trying to find is going to be negative 1 over 3. We also know that it passes through 7, negative 2. So we have a point, we have the gradient, so we're going to use the point gradient equation, which is y minus y1 equals mx minus x1. Substitute the values in, so minus our y1, which was -2. We have -1/3, x take away 7. So we can do some simplifying here. We get this, -1 here, x take away 7. I want to multiply my 3 up, so what that does is essentially puts brackets there, and we're going to expand it. So we end up with 3y plus 6 equals -1. So over here, this -1, we're going to multiply it by the x and the -7. So we end up with -x plus 7. Let's bring everything together. So I'm actually going to plus the -x here. That way I end up with a positive value for x. Let's plus it over here. And we get x plus 3y plus 6 equals 7. We want it in the general form, and remember the general form is where everything equals 0. So let's get rid of that 7. Minus 1 equals 0. So that would be the equation of the straight line passed to 7, -2, that is perpendicular to 3x minus y minus 5.